Good evening, everybody. Welcome to the evening edition of Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight, I'll be doing the review for test number 3, which I'll be giving this Monday online. All right, let's get to work. I should mention the file you see or what you see on the screen right now is available in the lecture section of D2L, cleverly named test number 3 review. All right, let's get started. First of all, there's a carboxylic acid, carbonyl, OH group, R group. How do you name them? Find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add OIC in the word acid. Remember, the carbonyl carbon is always 1, and we don't put that number down. Now, there are a couple of common names I would like you to know. First of all, when R is a methyl group in an acetic acid, in a carboxylic acid, got ahead of myself, it's acetic acid. And acetic acid, 4% acetic acid, approximately, and about 96% water. We call that product vinegar. And if you happen to pick up a bottle of vinegar you have in your home, that contains acetic acid, which is a carboxylic acid. If you pick up a bottle of ketchup, that contains vinegar, and vinegar contains acetic acid, which is a carboxylic acid. Now, when R in a carboxylic acid is hydrogen, we have formic acid. And I talked about how that's mixed with water, heated up, is the weapon, defensive weapon that the fire ants use. And finally, when R is a benzene ring, IUPAC in their infinite wisdom use the common name as the IUPAC name, and that is benzoic acid, which you should know. Now, carboxylic acids are called acids because they have an acidic proton. You react it with a base, and you get the carboxylate anion. Also known as a carboxylate salt. And a special case of that you should know, hint, is when you take a carboxylic acid and react it with sodium bicarbonate, which is found in baking powder, and you have an acid-base reaction. You get the carboxylate anion, water, and carbon dioxide given off as a gas. That's what this up arrow means. And that's because the carbonic acid that's formed in this reaction immediately breaks down quicker than that, actually, to water and CO2. And I hope you remember that I taught the story about the little rocket ships that had the awful candy in the world. You know it's awful when a 5-year-old won't eat it, dumps it in the garbage can. It was that bad. And my father showed me how to put vinegar, that's when R is a methyl group, with baking powder in there, put the cap back on, hold it, and the CO2 that would build up right here would cause it to fly off. Oh, that was so much fun. And my father also taught me that when you make spaghetti sauce, the tomato sauce contains citric acid, which is a carboxylic acid, and near the end, he'd put in some baking powder, and that would neutralize some of the citric acid and make it more smooth and milder. And I told that story. Now, how do you make a carboxylic acid? Well, you can take a primary alcohol and oxidize it to a carboxylic acid. You can also take an aldehyde and oxidize it to carboxylic acid. And one of my favorite, because you make a carbon-carbon single bond, which is something very special, very rare. If you take a Grignard, RMGX, where X can be chlorine, bromine, or iodine, react it with carbon dioxide, second step acid and water, you get a carboxylic acid that's one carbon longer than the Grignard you started with. Hold on. So let's have some fun. Let's clean this up first off. It's awful looking. That's better. And the question is, what would be the product or products for the following reaction? Your turn. All right, my turn. What's different? Remember, and I better go full screen on this. For test 3 and 4 in the final, your friends will always be 1. How many bonds to carbon? 4. I gotta get that finger fixed one of these days. 4 bonds to carbon. That's your friend. 4 bonds to carbon. The other thing, do you break carbon-carbon single bonds? No. Remember, do you break carbon-carbon single bonds? No, except for combustion, which isn't on this test. And the last thing I almost forgot to do, when you're looking at a molecule, look for something different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. Hopefully I got your attention. I'll say it again. Your third and final friend on my test in the final will be, when you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that, because that's probably where the action and fun is. So if we look at this first thing, CH3, CH2, ooh, magnesium iodide. That's a Grignard reagent. And remember, X can be chlorine, bromine, or iodine. And you react it with carbon dioxide, that's CO2, and second step acid and water, and you get this carboxylic acid that's 1 carbon longer than the R group you started with. Well, what's the R group? This. So we'll have CH3, CH2, my carbonyl right here with the hydroxyl group, and this is the product you get. By the way, this reaction I'll never put as a synthesis problem. Now, the next thing I started talking about were esters. And esters are carbonyl, carbon double bond to oxygen with an R group, oxygen to the carbonyl carbon. And on that oxygen is an R prime, more carbons. And this is an ester. How do you name it? For the IUPAC nomenclature, you should know R prime, you name as an alkyl group in the front. Now, there are two ways of naming the rest of the molecule. Now, 2A, step 2A, is the IUPAC method. You name, if R prime was an H, you name that carboxylic acid. You drop the OIC or the IC in acid and add ATE. Again, you name, if R prime was H, you pretend it is, even though in an ester it's not. You name it as the carboxylic acid it is, and you drop the IC in the word acid and add OAT. Now, I had a very clever Chem 170 student a long time ago who said, I've got a better way. When R is not a benzene ring, this method B2, if I say to be, or I'll say or not to be, that's the question. It comes from, I think, Shakespeare. But anyways, in B2, the student's method, which works every way, every time, except when R is a benzene ring, you name the longest chain, including the carbonyl carbon of the ester here, R and that's C. Name it as an alkane. Drop the E, add OATE. Now, there's one common ester I would like you to learn, and that's the one right here. When R is a methyl, R prime is ethyl, the common name is ethyl acetate. Nobody calls that ethyl ethanoate, which would be the IUPAC. Now, ethyl acetate, as I've taught in the videos, is one of the two molecules that's nail polish remover. Notice I forgot to polish my nails. Sorry about that. No, I don't polish my nails. But anyways, that's a nail polish remover. And as you learned earlier in ketones and aldehydes, acetone is the other. Now, since we now know how to name esters, let's talk about carboxylate anion nomenclature. And how do we do that? Well, here's a carboxylate anion, and it's very similar to esters. Now, name M plus, the cation, as the element it comes from in front. And for this class, I'm limiting that to lithium, sodium, or K, potassium. Next, there's two methods. The IUPAC is consider this carboxylate anion, if it was really OH, name that as a carboxylic acid, drop the IC in the word acid, and add ATE. Now, the student's method also works, except when R is a benzene ring. And in this case, like before, name the longest chain with the carbonyl carbon as an alkane. Drop the E and add OATE. Now, esters, you should know, are responsible for the smell of most flowers. Today, when I was outside, I was smelling the flowers around my neighborhood, and I was thinking, wow, those esters smell nice. And I'm probably the only one in the area who was thinking that. Now, esters are responsible for the smell of most flowers and the taste and smell of many fruits and vegetables. How do you make an ester? And that would be the synthesis. And that you take a carboxylic acid, react it with an alcohol, acid catalyst, H+, and you make an ester. By the way, it's really called Fischer esterification, named after discovered by the great organic chemist Emil Fischer, which you'll learn more about when we talk about carbohydrates and sugars. which is where he really made his name. But this reaction alone is a major lifetime achievement, and he did so much more. All right, let's take a run with this one. And it's your turn. What would be the organic product or products for the following reaction? 3 points each. Your turn. Time's up. Let's take a look at this. What is this? Well, we got a carbonyl hydroxyl group to the carbonyl and carbons. It's a carboxylic acid. And if we look at this carbon or this molecule, ooh, I've got an OH group on a carbon. That's an alcohol. I have acid catalyst and I form an ester. And what's our methyl? What's our prime? T-butyl. And therefore, I have my R group, my carbonyl, my oxygen, R prime. The carbon with the hydroxyl group here will be the carbon bond to the oxygen here, which is the T-butyl group. And I know there are 4 bonds to carbon, and I'll put in the rest of my hydrogens. Now, just like on test 2, on test 3, there'll be a couple of synthesis problems. So let's try one. And the question would be, what 2 chemicals do react with acid to form that molecule? Your turn. And by the way, those of you watching the video, if you want more time, press the pause button. Give everybody time to finish. All right, my turn. What's different here? Look for what's not carbon, what's not hydrogen. Ooh, oxygen here, oxygen here. We have a carbonyl, oxygen on the oxygen. We have carbons, I'll call that R prime. On the carbonyl here, carbon double bond oxygen, I have carbon. We have an ester. And how do you make an ester? A carboxylic acid plus an alcohol. What's R? This. What's R prime? This. And now I can write my carboxylic acid. Remember, you don't break carbon-carbon single bonds, so that our group is that way, and there are 4 bonds to carbon. So I can put in the hydrogen, and then my R prime, the carbon with the oxygen here is the carbon in R prime with the hydroxyl group. In this case, 2 carbons is the N carbon, and you get ethanol. And that's how you do a synthesis problem. Now, once you have an ester, what can you do with it? Well, it turns out a lot. If you take an ester and react it with acid and water, you'll get back the carboxylic acid plus the alcohol you would have used to make that ester. And we'll come back to this reaction because this is how your stomach breaks down fats and oils. But that's later in the semester. But here, ester, carboxylic acid, plus an alcohol. Now, if you take an ester and react it in base and water, now the base can be lithium, sodium, or potassium hydroxide. There are other ones, but I'll stick to this. You get not the carboxylic acid you would have used to make that ester, but in the presence of base, the carboxylic acid you would have gotten reacts to give the carboxylate anion. But you also get the alcohol you would have used to make that ester. Now, my favorite one, you know, Dr. White loves Grignard reactions, is if you take an ester and react it with 2 moles, that's with the 2 in front of R triple prime MgX, this Grignard second step water and acid, you get 2 products. The first one, you make not 1, but 2 carbon-carbon single bonds from the Grignard to get this alcohol. And the OR prime gets kicked out, we're violent, kicked out, to make the second alcohol. Now, this reaction I will never, ever give a synthesis problem on, but I will give the product or products. So let's try one. Now, on the practice problems, I forgot on the sheet, but not the answer, to put the 2 here. At my level, we never do because we don't balance things. But for this class, I put that in there, try to remember to put that in there. And on the test, I will. If I put this problem on, hint, and you'll get 2 products. That's what the plus sign is. Ooh, guess what? I have R on the brain. Let's try this again. And why don't you try it now? Every once in a while, Dr. White has R on the brain. It's curable. Your turn. What would be the 2 products when you do this reaction? All right, let's do it. We look up here, what's different? Ooh, oxygen here and here. We have a carbonyl, oxygen, R, OR, ester. What's different here? Carbon, magnesium chloride, and we have two of them. We have two Grignard reagents. And second step, acid and water. Let me just remind you, excuse me, X can be chlorine, which it is in our case, bromine, or iodine, those halogens. And keep your eye on the carbonyl carbon. This attacks both of them, kicks this out, and you get these two alcohols. First of all, you make not one, but two carbon-carbon single bonds, very special, very rare to make this alcohol. And then this part becomes this alcohol. So if we look up here, this is R, this is R prime, and this is R triple prime. So my R group, CH3, carbonyl, becomes this carbon right here with an OH group. And now the carbon with the Grignard, this end one of three, the R triple prime, not one, but two. And there are 4 bonds to carbon, so I know how to put in the hydrogens. And my second alcohol, R prime, is ethyl. And the carbon with the oxygen here is the carbon with the hydrox group in R prime. In this case, it's small ethyl. So you get ethanol. And these are the 2 alcohols you get. It's a lot of fun. Dr. White loves these reactions. And I use these in my research to get my PhD degree. Now, next we went to a new functional group area, talking about amines and amides. And this is something near and dear to my heart, because for a number of years I worked as a senior R&D manager for all the amine and amine derivatives for Axochemy, which was called then, now it's Neurion, for all of North America. And amines and their derivatives helped pay my mortgage and buy me a couple of cars and got me around the world. All right, what's an amine? Take ammonia, NH3, and replace the hydrogens with R groups. You have a primary amine, secondary, tertiary, which I'll never ask on a test, or the final. Now, I didn't ask you to learn the IUPAC name because everybody uses common names. Name the R group, each R group as the alkyl group it is in front, and add the word amine. Now, there's one special amine when R is a benzene ring. And remember, in an amine, the nitrogen has 3 bonds to it. It can also have 4, which I'll talk about in a little while. But in amine, the nitrogen has 3 bonds to it, and the remainder are made up by hydrogens. And when R is a benzene ring and you have 2 hydrogens, this is called aniline. And aniline is used for many things, like to make the dyes for our clothes, but I got a white top on, so it wasn't dyed, or also to make things like urethane foam, which you use for insulation, one type of foam, or it's used to make a key ingredient to help make rigid, flexible foam, which is used for your seat cushions, like in your car. Now, there's a special nitrogen derivative of an amine, and that's called the quaternary ammonium salt. And quaternary ammonium salts, I have a number of US patents in, I'm a world authority in it. And you have 4 R groups on the nitrogen. But because the nitrogen is donating 2 electrons from its non-bonding electrons, this right here has a positive charge. Since all molecules have a net zero charge, you need an anion. And there are many anions, but for this class, I'll keep it to the halogens, X equal chlorine, bromine, or iodine. Now, how do you name quaternary ammonium salts? Common name. Name each R group as the alkyl group and put that in front. And then add the words ammonium halide. And if it's bromine, Br minus, it's bromide. If it's Cl minus, it's chloride. If it's I minus or X is I minus, it's iodine. Now, I made a mistake here. Forgot all this. Now, if you have what's called an amine salt, and that is where you have a nitrogen with one or more hydrogens and one or more R groups. Now, the way I have it written, R prime, and R double prime can be carbon, or actually R prime and R double prime can be carbon or hydrogen. And these are amine salts, and you name them the same way as quaternary ammonium salts. You name each R group in the front, but you'll never have four, because if you have four R groups on that nitrogen, it's a quaternary ammonium salt, not an amine salt. And then you name the halide just like I have up here. Now, how do you make amines? If you take an alkyl halide, or in all these on this slide right here, X can be chlorine, bromine, or iodine with ammonia, and you need base to neutralize the HX that's made. And what you get is a primary amine. If you take a primary amine, by the way, the carbon in RX is the carbon nitrogen would be bonded to here. The carbon in RX is the carbon that the nitrogen in the primary amine is bonded to. And it's the same for the next three reactions. If you take a primary amine reacted with an alkyl halide, this attacks the carbon with the halogen, kicks it out, loses an H, it's neutralized by the base, and you get a secondary amine. You take a secondary amine and react it with an alkyl halide, same thing, this attacks that, kicks out HX, and you get a tertiary amine. Now, a reaction I did, this was actually the first research I did when I started working in the chemical industry a long time ago, not in a galaxy far, far away, but a long time ago, is hydrogenation of a nitrile. Now, just like a carbon-carbon triple bond, a carbon-nitrogen triple bond has 2 pi bonds and 1 sigma bond. And when you add hydrogen excess, remember the X and S in a bracket means you got all the hydrogen in the world that anything hydrogen can react with. You need a catalyst, and that can be nickel, platinum, or palladium. You break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens, which you see here. And that's a primary amine, which I can also write this way. Now, something near and dear to my heart, because it helped me make a lot of money when I was working at this company, Axo, and other people too, was if you take a tertiary amine, react it with alkyl halide in base, you get a quaternary ammonium salt. And I just have to show you. And the question is, what's the product you get? Now, R sub T, we'll learn later on, is called tallow group or tallow alkyl. It has 18 carbons with and without a double bond and carbon number C9. And I'll let you figure out first what's the product or products of that reaction. All right, what do we have here that's different? Ooh, a nitrogen with 3 R groups on it. 2 are tallow. Remember, this is the way we write 2 groups on a nitrogen. And a third one is methyl. And what's here? Carbon, ooh, a halogen, and alkyl halide. So we have a tertiary amine, alkyl halide base. We get a quaternary ammonium salt. And it doesn't matter which side you put which R group. And the halogen anion. Don't forget that. And let's call this R and R prime. Let's call this R double prime. And the methyl group R triple prime. You can write it like this. If you don't show the charges, I won't take off points, but I do because I think it's cool. Dr. White likes to be a cool dude. Or you could have also written it this way. And this is ditallow-dimethyl ammonium chloride. And for many, many years, until about 15 years ago, this was the only molecule used as fabric softener, which I know a lot about. And you should know quaternary ammonium salts can be fabric softeners or antimicrobial compounds, as I mentioned on the video where I talked about the mouthwash. If you look there, I think I had a show and tell of the scope type, which I actually go to Walmart and get their equivalent, which is a lot less expensive. It's the same. And that has also a different quaternary ammonium salt that helps keep my gums nice and healthy, which is a good thing. Next, I talked about amides. And amides are where you have a carbonyl R group, nitrogen with R prime and R double prime. Now, R prime and R double prime can be hydrogen, or they can be both carbons or one hydrogen, one carbon. And how do you make an amide? You take a carboxylic acid and react it with either ammonia, that's when R prime and R double prime are both hydrogen, or primary secondary amine, and you make an amide. Now, like an amine, the nitrogen amide always has 3 bonds to it. Amine salts and quaternary ammonium salts, the nitrogen has 4 bonds to it. And this is how we make an amide. Now, once you get an amide, you can react it with hydrochloric acid. Guess what? That's the acid in your stomach, which I always think of, wow, that's a miracle of life. Our stomachs, like mine and yours, has cells that manufacture hydrochloric acid, HCl. Amazing. And it uses it to do this reaction, which I'll teach you later, involves proteins. But let's look at the amide. You get back the carboxylic acid you would have used to make that amide. But amines are basic. Did I forget to talk about that? Nope, I think I forgot that reaction here. But amines are basic, and I'll write that reaction down in a second. Now I have it right here. I just skipped over it. Take an amine, acid, base, acid, you get a salt. So if you take a amide and react it with HCl and water, the amine you would have used to make that amide becomes the amine salt, because in the presence of acid, the fastest reaction known in chemistry are acid-base reactions, and you'll get the amine salt of the amine. Now, if you take an amide and react it with base and water, sodium hydroxide, the carboxylic acid you would have used to make that amide is really the carboxylate anion, since the carboxylic acid reacts with base, but you get back the amine. Now, remember, R prime in an amide can be, and double prime, one, both, or none, can be hydrogen. Now, finally, I talked about heterocyclic compounds, and you should know what is a heterocyclic compound. That's a ring with carbon atoms and other atoms, such as oxygen or nitrogen. And I asked you to learn one heterocyclic compound, that's pyridine. It's like a benzene ring, but one of the carbons in the six-membered ring is a nitrogen. And this is a very important molecule, and other amines I talk are heterocyclic, but I'm not going to ask on the test. Well, I'm just about done, but there's one last thing I thought we should do before I let you go. Let's play that fun game. Let's play that fun game. Circle and name the functional group or groups in the following molecules. Here's one for you to work with, and let's do one more. That's Na. And have fun. Circle and name the functional group, 2 points each. All right, time's up. And if you need more time, hit the pause button now. Look for what's different. Ooh, oxygen here and here. What do we have here? Carbonyl, R group, oxygen and the carbonyl, R prime. This is an ester. Ooh, nitrogen with 4 groups attached to it. And a halogen anion. Remember, X can be chlorine, bromine, or iodine. And what is this? This is a quaternary ammonium salt. And let's go on to B. What do we have that? Ooh, oxygen here, oxygen minus, and a carbonyl. Carbons here, and a cation. And that's right here, a carboxylate anion. We're not the, ooh, a nitrogen with carbons and hydrogen. And what is this? It's an amine. Are we done? No. Up here, oxygen, carbonyl, the carbon here, and we have this running out of room here. And what is this? This is a carboxylic acid. And that's how you play the fun game, circle and name the functional group, 2 points each. And with that, I'm done. Don't forget, this Monday, I will be giving test number 3 online, starting at 8 a.m. I'll send out the password, and then I will be letting you have until the next day, 4 p.m. Tuesday. Hopefully by Wednesday, I'll have it all graded, and then I'll send out an email for that your scores in D2L, and also send out individual emails to each of you for each point you get on test number 3. With that, good luck. Have a nice rest of the week. I'll say gang gesund. Remember, that means Yiddish go in health. Goodbye now. I stole that from Granny and the Beverly Hillbillies. Bye now.